Good afternoon, everyone. For my case study, I decided to focus on kindergarten skills of counting and cardinality. This study is based on a general education classroom of kindergarten students and also with the alignment of Alabama Course of Study standards, specifically Alabama Course of Study standards for kindergarten with B4, B5, and A3 under the context and domain of counting and cardinality. The purpose of this analysis is not just to identify what students are getting wrong, but actually to dive deeper and to understand how they are thinking. So about numbers, so we can better understand their conceptual understanding. So, going to my next slide here, basically, again, a summary of what I just said with my introduction. Basically, we want to help those students, which I would say my background when I was taught was student teaching, even up until now. Basically, we're just now beginning to train teachers how to dig deeper and to not just pay attention to the fact that a student made an error or scored something incorrect, but to dive deeper into their thinking. And also, not just for the teacher, but also for students to think about their thinking. All right, so getting into the framework, the primary framework I chose was the trajectories framework. And sorry, my slides did not come out quite perfect. So this framework explains understanding through predictable stages, moving from basic to the more complex and a very procedural way. You must have one for the other. I guess you could say more predictable stages, more so to say. In this case, the focus is on early counting development, and students learn by beginning to say number words in order. Over time, they must connect the number words to actual quantities. That's some of the first skills that kids are taught, especially in pre-K or infants in early learning or preschool classrooms are taught to count. To make this clear for everyone and to clear up, because I know that everybody may not be an early childhood person, so I wanted to clarify some terms I will be using that you may need to understand. Number one, I may refer to one-to-one correspondence. This means basically when you're counting something that you are basically, you're not just, let's say if it's a group of stars, you're not just going 1, 2, 3, 4, 5, 6. Basically, they're lining up a star with a number, or not necessarily lining up in a line, but in their mind, they're associating with counting one object for each number that is said. So that is called one-to-one correspondence. Also, cardinality refers to the understanding that the last number that was said refers to how many are in a group. So, for example, I have 5 fingers and I count 1, 2, 3, 4, 5. Then cardinality means that I know that 5 was the last number that was said. So therefore, I am able to conclude that I have 5 fingers. Also, rote counting refers to just basically the way we count orally 1, 2, 3, 4, 5, 6, 7. That is called rote counting. So in summary, using this framework is going to allow me to interpret student behavior, such as if they skip objects, if they don't have any counting strategy, such as lining up or starting from the top to the bottom. Doing the one-to-one correspondence is also a strategy and a skill at the same time, and where they're developmentally heading towards mastery. So, in going forward, to give a little background, the diagnostic findings were showing that students perform relatively well on counting tasks, and they were able to count a set of objects correctly. But later on, the data showed that students did not know how to write the numbers correctly for a group of objects. To represent groups of objects by writing the number, so which is also in relation to counting. In addition, I observed some objects counted more than once. Students had to recount when I asked how many. Basically, they had to rely heavily on counting an actual object instead of being able to count mentally or being able to associate what they count with the group. And so they actually had to actually have physical objects. And we know that in real life, so that they're at the concrete stage. We know that in real life, when you count, we're not always able to actually touch that object. If we're counting cars, or how many cars are lined up in traffic, or how many corners we have to go to, or how many blocks we have to make, we're not actually able to touch them. We're representing them in our mind. And so this is very important to understanding and diagnosing student misconceptions. Also, students are not yet demonstrating full understanding or cardinality. So even, like I said, they can count correctly, but they're not able to represent the total number or the final number. So the assessment tool that was used was the mid-year universal screener. This allowed me to observe student behaviors in the interview format, watching the teacher administer the test. I also administered some items, as a certified teacher and coach. However, there were some limitations to some of the questions in the assessment. Number one was that there were not questions that allowed me to address their reasoning, which made it a little harder to fully understand their reasoning. So I have some data, but I can repeat these same tasks as a progress monitoring tool to see later what their thinking is. Also, moving forward, I would include more opportunities for students to use different arrangements to better assess. Sometimes it could just be the objects. So sometimes it can be actually the tools or how it's presented. We know that sometimes we can understand the question, and then oftentimes when it's rephrased, we're like, oh, okay, I understand what you meant. And it was presented a different way. So that's something I would like to dive deeper into as I go forward with this case study. For research focus, based on these findings, my action research will focus on instruction and how I can help students basically become better counters, go from the concrete to the abstract. Basically, I want to move them from simply performing counting procedures to actually understanding quantity. Also, that's something that's built in for those of you who might be elementary with number talks, the skill of subitizing, looking and having a mental strategy of immediately assessing how many there are there. So we know that that's important because going forward, as the numbers get larger, they won't always be able to touch everything one-to-one. So this is an important, it's where it all starts. It's the foundation. So this is an important skill. So in closing, overall, this case study highlights the importance of understanding how students think, and just not whether or not they are correct. By using the developmental framework, I will be able to identify, and I can identify where students exactly are in their learning and design interventions and instruction that will help them make the connections between counting and quantity. Thank you so much for your time.